Let's start another problem. In fact, this is the same problem which we solved in the previous video, but with a little more complexity. Okay, and the complexity comes in the form that the speed now is not constant, but the speed changes is now changing at a rate of say 5 meters per second. Sorry, meter per second, but not with respect to time, but per meter. Okay, so that means every meter the particle moves on this path, the speed changes by 5 meters per second. Okay, so then again, still we are supposed to find out what is a1, a2, and a3. So that's still the question. Okay, as usual, we will write the general formula for finding out the acceleration at a point in the anti-coordinate system. Okay. And in the previous video, we saw how to calculate these vectors. So now that's not an issue. So having said that, we should now concentrate on finding out these things, these two factors. In the previous problem, these two were very easily calculated because this was 0 and this was given to be 5. Now it's given that the speed is changing at 5 meters per second per minute. So how to do that, convert that into this form? See, any acceleration, when I'm saying acceleration here, I'm just talking about the rate of change of speed with respect to time, is nothing but dv over dt, right? Now this, because we know how the velocity is changing with respect to distance and not time, so we can write this as dv over ds times ds over dt, because this is what is known to us. Okay, and now if we write like this using the chain rule, this again comes out to be the velocity. So we can say that this is nothing but v dv over ds. Okay, so here everything we are talking in terms of the magnitude of the so this is in a way speed. I'll say this is speed. This is this rate of change of speed with respect to distance, and this is rate of change of speed with time, time rate of change of speed. Okay, so this is the setup. Now if so what all we know, what we need, so this let's calculate then a1. Fine, a1 is the acceleration which we want to calculate for this point a1. Now for that we need to have the velocity also at that point, right? So now what is the velocity at 1? Velocity will be, see, the point started at this point with so that I didn't say. So at the initial point A, the velocity was given to be 5 meters per second. Okay, it started with that 5 meters per second. So now v1 will be that 5 meters per second, which is at A, plus by the time it reaches B, it would have traveled this distance, right? Which is nothing but pi over 2 times the radius 2. So this distance times this 5 meter per second per meter. So okay, so then this will give us around 20.7 meter per second. So this is like ds over dt at 0.1. Fine. If that is so, then what is now let's calculate d square s over dt square, which is nothing but this term, right? Now this is we say that velocity at that point time dv by ds. So what's the velocity? So velocity times dv over ds. Fine. So velocity has been calculated to be 20.7. Then dv by ds is 5. This is that. So that's the value of d square s by dt square. Now we are in a position to write the acceleration a1. Fine. And as usual, we know the direct et for this. I can write it here directly. We can write anyways. So a1 is we can calculate 20.7 times 5. Then et is I cap. Then plus this is ds over dt is 20.7. Its square divided by r, which is 2 times j, because okay, here I'll write that et is I cap, here this one, and en is equal to j cap, right, at 0.1. So this is what you'd get as the acceleration of 0.1. Fine. Then coming to say acceleration at 0.2. Fine. For that, let's again calculate v at 2. V at 2 will be 5 meter per second at the point A again. Fine. Then by the time it reaches, what's the distance it would have traveled? So this full semicircle plus this. Okay. So this would be plus. So that angle is pi times 2. This is the bigger semicircle plus. That's 30 degrees. So pi over 6 times 1. Fine. So that's the distance traveled and 5 meters per second meter per second per meter. Okay, so this is in meter. Yeah. So this is the velocity which you will get. Velocity in the sense speed, basically I'm talking about, at the point 2. Once you get that, now we are in a position to find out a2. Fine. So what would be the d square s by dt square at this point? It will be v dv by ds at 0.2 et plus this v2 square over 1 en, right? So which is nothing but velocity is equal to how much was velocity? 39 into 39. Okay. 39 times 5. Okay, so this is times et plus 39 square over 1 en. Okay, but now what is et? How much? You see that now et is equal to now if that is 30, let's see. So this angle is, so this is 30, so this is 60 degrees, so this is en, this is et. Fine. So et will be cos 60 degree into I plus sin 60 degrees times j. Fine. See this? Cos 60 times in the x direction and sin 60 times the j direction. And similarly, en would be say cos 30 degree times I and minus sin 30 degree times j. If you look at this en, so this cos 30 times this, and this direction is minus sin 30 j. So if you substitute this, you should get a2 should be equal to 1415 I minus 592 j. Okay, and similarly, if we come to finding out a3, fine. Now for a3, see, this term doesn't contribute anything, this term, because r is infinite anyway, so only this term we have to calculate, and that is nothing but now a3 is equal to d square s over dt square, and et which is nothing but negative of j cap. Okay, so that is v at 3 times dv by ds. v3 is how much? So that you have to calculate as 5 at a plus, now what is the total distance traveled? The distance traveled is, say this is pi times 2, the first semicircle, then again pi times 1, the second semicircle, and then half a meter distance, right? So this half a meter, so this is first part, this is second part, and this is the third part, half a meter. So this times 5 meter per second per meter. Okay, so this time here I missed et. Okay, so this full thing times et, so implies a3 vector should come out to be 273 j cap. This minus j is coming from that. Fine. So all these things are anyway meter per second square. This is also in meter per second square, and this also is in meter per second square. Fine. So it's the same problem which we had solved earlier, but here just we had an additional information that the speed was not constant. Fine. Then we will stop here for this, and we will solve another problem in the next video. Thank you.